Hey there, Lorenzo. How are y'all today? Um, Hello. So I was made aware that y'all had some technical issues getting y'all's quizzes uploaded on Friday. Um, Amaris, I got your quiz uh, on time, um, and your facilitator sent me the quizzes for Alex, Ariel, and Lucero. I've got those uploaded. Even though they say that they're late on my end, I'm going to disregard that when it gets to when it comes to me grading those. So I do have your quizzes uploaded, and we'll get to grading those probably at some point tomorrow. Okay? All right. Um, so, what do we have going on? This week we conclude Unit 3. Uh, we are basically doing assignment 18, which is properties of logarithms, and then we have 19 and 20 that deal with equations, logarithmic equations and exponential equations. That will conclude Unit 3. As of now, the exam 3 is scheduled for Monday and Wednesday of next week. Notice I said as of now. Um, I'm debating on whether or not I want to change that to a Wednesday, Friday of next week, to keep that in line with um, our coursework. That would mean that we'd probably start assignment 21 on Monday. Um, I'll let you know by Wednesday what my final decision is. Um, so next week is exam week. Then the following week is Thanksgiving week. We only meet for Monday. Um, and then after Thanksgiving week, we have 2 full weeks of class, and that will wrap up Unit 4 material. And then we will be taking our final exam. So, yeah, the semester is quickly coming to a close. Um, so, as far as what we're dealing with today, um, we are talking about solving or dealing with assignment 18, properties of logarithms, and we can talk about that homework set or any of the previous homework sets. So as I like to say, the floor is yours. How can I help you with any of your assignment work?
What's due this week?
What is due this week?
Yes,
Uh,
because on Blackboard it says that 18, 19, and 20 is due, but you have the notes 19, 20, and 21 on week 11.
in grade scope?
Yes.
So on grade scope, it says 1920. Oh, yeah, I see. So I'm gonna have to make that correction. All right, thank you very much, Jermaine. I'll see you in class. Okay. Yeah, so that's, man, I hope I don't have to correct a whole bunch of stuff. So probably gonna have to correct a whole bunch of stuff. That's alright. Ah, I'll get that corrected, but it is 18, 19, 20. Basically, as you see it in Blackboard, that's what's due this week. Sorry about that confusion.
So we're gonna have to do the same thing that we did last weekend since we submitted assignment 16, but we all submitted assignment 18. So do we have to submit it again this week?
So week 9 was week was, this is week 10, right? No. Yes?
It's week 11.
It's week 11. So week 11, all you're supposed to do for week 11 was 16, 17, and 18. Oh, I apologize. So I think I misspoke. In your initial question, you asked what was due this week. Did I say 18, 19, and 20?
Yes.
So I misspoke. That's it is 19, 20, and 21. We are on track because y'all submitted assignment 18 last week, correct?
Yes.
Good. This week is 19, 20, and 21. You had me scared for a moment. I was just brain fog. We are on track. Okay? Yeah. All right. Don't scare me like that. Okay. All right. So, assignment 19. How's it going? Good. Any questions?
Number 9.
Number what?
9.
9. Yes, number 9. We want to expand the natural log of, we have bracket, division bar. In my numerator, I have a 5x squared, the square root of a 3x plus 1. And in my denominator, we have a 2, open parentheses, x plus 1 cubed. Okay, so the first thing I notice is this division bar. And anytime that we have a division bar in a logarithm and we're expanding, we're going to use the quotient rule to expand. So that means the quotient rule is going to basically break this apart into two logarithmic statements separated by the subtraction sign. So this becomes the natural log of our numerator 5x squared square root of 3x plus 1 minus the natural log of 2x plus 1 cubed. Okay. Now, let's look at this first statement over here. What's happening? Everything's being multiplied together. Your 5 is multiplying the x squared is multiplying the square root. So, since we're multiplying, we get to use the product rule. And we're going to expand. So this becomes the natural log of 5 plus the natural log of x squared plus the natural log of square root of 3x plus 1. Now, before we say the same thing over here, because what's happening here, natural log of 2 times that x plus 1 cubed, we have to recognize what this minus sign is doing in front of that natural log. And so I want to do a quick little slide example just to show you what's about to happen. Consider a negative 6. This is just a quick little example. Now, negative 6 is the exact same thing as the negative of 6. Exact same thing. Put equal sign. Which 6 can be rewritten as, I don't know, a 2 plus a 4. Now, what is that minus sign going to do? That minus sign is going to distribute, right? So this becomes a negative 2 minus 4, which we all agree, yeah, duh. Negative 6 is the same thing as a negative 2 minus 4. Well, you have to be thinking about that with this statement as well. And in fact, what I'm going to do to do this is I'm going to actually put this natural log of 2 times x plus 1 cubed in parentheses. So now you have minus the natural log of 2 plus the natural log of x plus 1 cubed. And now I'm going to take that subtraction sign and distribute it so that we now have minus the natural log of 2 minus the natural log of x plus 1 cubed. And that's how I answered the same question in the previous class, and there's a confusion about why is the last term negative, and that's why. The last term is negative because when you expand this logarithm, the negative sign in front of it is going to have to affect the entire expansion. For the same reason here, you can't say that negative 6 is the same thing as negative 2 plus 4. That's not true. Negative 6 is the same thing as negative 2 minus 4. So these must both be minus. Good with me so far? Makes sense so far? So the last thing that we can take care of is anything that has an exponent. So anything that has an exponent, we can use that product rule. And I'm going to circle that square root. Why is he circling that square root? Well, let's see. So we have the natural log of 5 plus, what does the product rule do? It takes the exponent and brings it out in front of the logarithm as a coefficient. 2 natural log of 2. 2 natural log of x. Plus, now why did I circle the square root of 3x plus 1? Because the square root can be rewritten as an exponent of 1/2, which in the next line, in the final line of work, I'll bring that 1/2 out in front. Continuing, we have the minus the natural log of 2, and we'll bring that 3 out in front of this logarithm as a coefficient, minus 3 natural log of x plus 1. And last line of work is going to bring that 1/2 out in front of the logarithm, so we have the natural log of 5 plus 2 natural log of x plus 1/2 times the natural log of 3x plus 1. I must emphasize that you need to keep that 3x plus 1 in parentheses because you're taking the natural log of all of it. Minus the natural log of 2 minus 3 times the natural log of x plus 1. If you don't put the parentheses around the 3x plus 1 or the x plus 1, it's like saying you're taking the natural log of x and then you're adding 1. Whereas here you're taking the natural log of x plus 1. You're taking the natural log of all of it. And that's our final answer. That is the problem completely expanded. Alright, does that make sense? Good.
Can we go over number 3?
Number 3? Yes. Alright, before I do number 3, I just want to do a little quick preview. P-R-V-I-E-W. Preview. Preview for problem number 3. I'm going to do something very simple, and then we're going to apply the simple answer to problem number 3. Let's suppose that I had the natural log of x minus the natural log of y minus the natural log of z. And we're going to condense this. Alright. I don't remember how I did this in the notes. I probably did it left to right. So if I'm going to go through and condense this, one way to do it is do this left to right. So we'll take a look at these first two terms. Because of the minus sign, that means we're going to do a quotient. So this becomes the natural log of x over y minus the natural log of z. Okay, with me so far? Makes sense? Now again, there's a minus sign. So that means I'm going to do another quotient rule. So this is where it gets a little bit crazy. So here's your division bar, in the numerator you have the x over y, in your denominator you have the z. Never, ever, ever leave an answer as a complex fraction where you have a division bar and either a fraction in the numerator or the denominator or both. So what do we do here? We have to recognize that that z is a z over 1. Then I can bring that up to the numerator by doing its reciprocal. So that becomes the natural log of x over y times a 1 over z, which is the natural log of x over yz. Alright, so that's one way to do this problem. That's just one way to do it. So the other way to do this problem, and this is the way I'm going to approach problem number 3. The other way to do this problem is to, what I'm going to do is I'm going to do some, well, I'm going to leave those terms in the order that they are. Notice that you have a positive term and then your negative terms. So watch what I do. I have the natural log of x minus, now I'm going to put in parentheses the natural log of y plus the natural log of z. So essentially I just factored out the minus sign. I just factored out the minus sign and put these together in parentheses. Now here, I'm going to use the product rule. Natural log of x minus the natural log of yz. So using the product rule, because there's a plus sign, I brought these two together. Now, because of the minus sign, I get to use the quotient rule. We get the natural log of x over yz. So you get the same thing, but in my mind, and this may not be the same for you, but in my mind, it's much easier to do this because I'm not dealing with that complex fraction. Do you see what I'm getting at? It's much easier to factor out the minus sign, deal with this as a product rule, then you have one logarithm, then I just use a quotient rule to get this. Y'all see what I just did? Does that make sense what I did? That's the way I'm going to approach problem number 3. So let's take a look at problem number 3. Problem number 3. We have the natural log of 2x plus 1 minus the natural log of 3 plus the natural log of y minus the natural log of z plus 2 minus the natural log of 5. Now, what I'm going to do is I'm going to set this up so that, like up here, I have all my positive coefficients, positive logarithms first, and then all my negative logarithms after that. So my positive logarithms are the natural log of 2x plus 1 plus the natural log of y minus the natural log of 3 minus the natural log of the z plus 2 minus the natural log of 5. So I just did a quick rearranging of terms. So I can put these two together using a product rule, So this becomes the natural log of 2x plus 1 times y. And now what I'm going to do is I'm going to factor out the negative. So let's just write that out in different color. Factor out the negative. So this becomes the negatives of the natural log of 3 plus the natural log of z plus 2 plus the natural log of 5. Okay, now I'm going to go back and use the product rule on those three guys. So we have the natural log of 2x plus 1 times the y minus the natural log of 3 times the z plus 2 times the 5. And now I'm going to use a quotient rule here. I'm running out of room, so we're going to squeeze that in. Bet I can squeeze it in right here. This becomes the natural log of, in my numerator, I have a 2x plus 1y. In my denominator, now I'm going to do a quick thing. I'm going to take a look at this 3 times a 5. 3 times 5 is 15. So we have 15 times the z plus 2. And there is our final answer. Now, you might have the question of how come we don't distribute the y and how come we don't distribute the 15? There's nothing wrong, I would say. I would say that there's nothing wrong with distributing the y or distributing the 15. I would just say that this is a simpler answer than distributing. I would say that it's better to have a product of items in your numerator or denominator rather than a summation. Yeah, we're dealing with the summation of 2x plus 1 right here and the z plus 2 down here, but at least I only have, instead of, 3 things up top and 3 things down below, I just have 1 thing up top and 1 thing down below. That's I guess my best answer for why we don't distribute. Now, if you do distribute the y and distribute the 15, I'm not going to count off. You're going to make me think when it comes to grading, because this is going to be my answer right here in my answer key. And if I see a 2xy plus a 1y up top, I'm going to have to think, all right, well, what did they do? And I'm going to look back to your work, and I'm going to say, did you get to this point right here? And I'll say yes, and I'll circle this and check that. You're just going to make me work harder when it comes to grading. So you don't have to distribute the y. So why did we distribute the 5 and the 3? Well, because it's not that hard to multiply 5 and 3 together. Does that make sense? Good. What else can we look at? Have y'all finished the homework, or are y'all still working on it?
We're still working on it. I'm trying to find the question that I had a while ago about it.
Okay.
Can we go over number 5?
Yes. Okay, problem number 5. Let's see. We want to condense one half times the log of x plus the log of that one half, there we go, plus the log of y minus the log of z. Alright, and if you'll notice, the answer key has a couple of different options for you as far as your answer goes. So how would I approach this? I don't know. My first inclination might be to use that power rule. Well, let me put it this way. Let's because not using the power rule just yet. Let's take that one half and distribute it to each of my 3 logarithms. So you have 1/2 times the log of x plus 1/2 times the log of y minus 1/2 times the log of z. Now we'll use that power rule to bring those coefficients in as exponents. So we're using the power rule right here. So this becomes the log of x to the 1/2 power plus the log of y to the 1/2 power minus the log of z to the 1/2 power. And then just a little side note, I will then consider the fact that x to the 1/2 power is the same thing as the square root of x. So that means I can rewrite each of these as now the log of the square root of x plus the log of the square root of y minus the log of the square root of z. And then I can start thinking about my product and quotient rules. So because of the plus sign right there, I can condense these two guys with a product rule. So that becomes the log of the square root of x times the square root of y minus the log of square root of z. And then because of the minus sign, we can condense these using a quotient rule. So that becomes the log of, here's my division bar, in my numerator I have the square root of x, square root of y, over the square root of z. Okay, now that's how you get one of the answers in your answer key. And you'll notice in the answer key I said or. Another way to look at this problem is we could go ahead and condense the logarithms inside before distributing that 1/2. So you could have 1/2 times the log of, and let's just kill 2 birds with 1 stone. These two are condensed with the product rule, and then you'll use the quotient rule to condense it with the log of z. So you have the quotient of xy over z, And then I can use the power rule to bring this into the logarithm. So it becomes now the log of xy over z raised to the 1/2 power. Now, how do you get, I mean, are these the same? Are these equal to each other? Well, sure, they're equal to each other. So, if you recall, the power rule, or it's actually called the product to a power, product to a power rule for exponents. This says that if you have a times b to the n, that's equal to a to the n times b to the n. Basically, everything gets raised to the power of n. So you can continue doing your work up here to now say that you have the log of x to the 1/2 power, y to the 1/2 power, and z to the 1/2 power. And we know from this statement over here that the 1/2 power is equivalent to the square root, so that gives you the log of the square root of x, square root of y, over the square root of z. And that's how you get to that statement right there. Okay, does that make sense?
Can we go over number 7?
Yes. Number 7. So number 7, it's basically going in the reverse of problem number 3. It's basically going in the reverse of problem number 3. So let's start off with, in problem number 3, we got this solution, right, where we were condensing. Well, let's unwrap that. So if this was our answer, the previous line of work was this. So how did we go from here to here? We use the quotient rule. So to go backwards, you're going to use the quotient rule again. So what I'm going to do is, because of this division bar, let's use the quotient rule. So that becomes the log of x squared y cubed minus the log of z to the 9th. Okay, so do you see how I'm using problem number 3 as a guide? Does that make sense? So what do we do next? So we went from we got our answer To get to their answer, we use the quotient rule. To get to this statement, we use the product rule. We basically want to expand these two logarithms, or this logarithm, into two logarithms. So I want to, because I have a multiplication sign right there, we want to use the product rule to expand. So that becomes the log of x squared plus the log of y cubed minus the log of z to the ninth. And so my question to you, and you can look back at what we did over here, what are we going to do next? What can we do next? What can we do next?
Move the exponents to the front of the logs.
Yeah, and what rule is that? What rule are you using?
Power rule.
The power rule. We're using the power rule. So what we're going to do is bring those exponents out in front as coefficients. So it becomes 2 log of x plus 3 log of y minus 9 log of z. Alright, oops, sorry. Um, we only have a few minutes left. Is there anything else I can help y'all with?
I think that's it.
Could you say that again?
I think that's it.
Okay. Alright, well, if that's the case, um, we will be starting, what, assignment 20, which is, exponential equations. We'll be doing exponential equations on Wednesday. And I will let you know about my final decision about, exam 3, whether it's gonna be next week, Monday and Wednesday, or, next week, Wednesday and Friday. I'll be thinking about that between, today and Tuesday, and I'll also get a review out for Unit 3. I'll put it in the week, whatever week this is, folder, week 10
Your
folder.
conference is scheduled to end in 2 minutes.
Is it week 10 or week 11? I can never keep up. Week 11 folder. Alright. So I will see y'all on Wednesday. Take care of till then. If you have any questions, just shoot me an email. Bye.
Your conference is now over. Goodbye.